So yesterday we saw one code like I was mentioning on the baseline building, like I was saying like so which code which I was referring to? Do you remember the code where I was saying if you want to conduct a energy performance simulation, for the base case modeling, I was saying like you need to consider parameters based on a certain code. Yeah, exactly. Yes, you got it right. So what's the full form of PC basic? Perfect. So have you gone through the codes now? And yeah, that's what I'll just come up to it. Okay, I'll touch upon like ECBC is the code which is currently implemented. So it is 2013 as you told. It is only for the commercial buildings. And are you Econiva Samhita, it's for the residential buildings. So in that only we have seen about the RETV and all. So if you see the last year electricity consumption pattern, like the 24% of the consumption is accounted from your domestic, that is your residential, and 8% is from your commercial. So put together, if you see, 1/3 of the electricity consumption comes from the building sector. So if you see, so if you see, like India aspires to be developed nation by 2047. So this way, the current proportion 33%, which will become now close to 55%. That is the reason like government wants to focus on this sector, try to regulate and optimize the electricity consumption, which is coming from the building energy sector. So what they have done is they have passed the amendment to the EC Act, Energy Conservation Act of 2022. So now this ECBC code has become ECSBC. So this S stands for Sustainable Building Code. Generally, ECBC is Energy Conservation Building Code, whereas ECSBC is Energy Conservation Sustainable Building Code. And this code, again, both of these codes applicable only for your commercial buildings. And what is the new change they have bring in is they have also added the green elements to it. Like apart from focusing just on energy conservation, they have also added your water, waste, indoor air quality, and like the green buildings which we saw, no? So those criteria they are. So any idea on the applicability of this code? They have prescribed a certain criteria actually. So can anyone state what is the applicability? Okay, I mean these are the commercial buildings that applies to it. So okay. So it applies to a commercial building with a connected load of 100 kilowatt or a contract payment of 120 kVA. So do you understand by connected load? What do you mean by connected load? Any idea? Correct. That is like the demand which we generally get. So connected load is something like the wattages. For example, if we take this light, let's take 25 watt of this. Then in this room, account for how many lights are. So the lights multiplied with what. Similarly, it happens for your other equipment. So put together, if it reaches 100 kilowatt, more than it, then this code will be applied. So from glazing point of view, let's take built a floor area. So how do we represent an equivalent value to an 100 kilowatt? So let's take a building with a built-up floor area of 2,500 square meter. Generally, for a commercial building, like the connected load, again, it's going to vary based on your design. So let's assume that in a commercial building, that value will be 0.4 watt per square feet. So it's just like, so yeah.
You have to point it this side, huh?
This side. Okay, perfect. So if it is like 40 watt per square meter, let us assume that. So you multiply 40 watt into your 2,500 square meter. So it will come up. How much? So your built-up floor area is 2,500 square meter. The connected load will be 40 watt per square meter. So if you multiply together, 10,000 or confident fan. 1 lakh. No, it is 1 lakh watt. So if you divide by 1000, that will come to 100 kilowatt. So any building approximately which is having a built up floor area of 2500 square meter, this code will be applicable. So when you see that glazing area, typically a building will have like window to floor ratio, 30% of window will be there. So accordingly, so the glazing area would come up to 750 square meter. So if a building is going to have 750 square meter of glazing, then it is a high chance that it will complies with 100 kilo.
Oh.
Okay. The next question is that generally when we go to the market, the builder will ask us why we need to go for this code. What is the benefit? For example, generally if you take a green building, there's a benefit which the developer will get in terms of additional FSI. But what is the benefit that he is going to get? Well, if you see in this terms of code, there is no actually direct benefit to the developer. Only thing is that if you are going to comply with this code, he is going to get the reduced electricity consumption. Like the user only is going to get the benefit. Then he will ask us the question why I have to go for this complaint, because obviously he has to incur additional cost to comply with this. So the thing is that what happens in this thing is it is bound to a legal requirement side. So he will be bound to follow this code. So only if he is going to comply with this code, in going forward in future, building OC will be given, occupancy certificate, and also your permanent electricity action will be given. And also yesterday, like we saw, it is also related to your green building certification. Like the IGBC says that for your baseline building, you should take the criteria from your ECMT. And Griha also says that there is a clause in Griha that you have to comply with the mandatory requirements of ECBC. Then only the certification will be provided. Like we saw, no, there will be mandatory criteria as well as prescriptive criteria. Okay, as I was saying, so the code talks about various section. In that, we'll now discuss on the building envelope. Okay, so when it comes to the performance level, like in the rating system, we have no platinum, gold, silver. So when it comes to this code, it is like ECSBC, then ECSBC plus Super ECSBC. So Super ECSBC is what your highest standard. And for complying with the ECSBC, you just have to meet the minimum thing. So your proposed should be equal to the baseline conditions. If it is going to be lesser, like your proposed design is going to have lesser consumption than your baseline, then it is going to meet AC SPC plus. Like if you take what happens now, the condition will become more stringent. Let's take for example, if you are complying with the basic EC SPC code, and if you take a conventional building, that building is going to say EPI. You are all aware of EPI, no? So for a typical building, commercial building, let's take EPI would be around 200. So if the building is going to follow or comply with the ECSPC, then that building EPI will come to 150 kilowatt. If it is going to comply with ECSBC plus norms, then that EPI will become 125. If it is super ECSBC, then it will become 100 EPI. So you can see 50% like energy reduction will happen if you are complying with super ECBC levels. So okay, this is the current status. This is how like the ECBC code is implemented. So the green code, that is the stage where this code is actually notified. So actually, if you see for implementation, generally the state government has to notify, for which it has to pass through an assembly thing and all. So they have to give the consent, then only it is amended into the building bylaws, local bylaws, then only we get enforced. So currently, if you see the yellow states, where typically, Gujarat and Maharashtra, where you have lot of potential solutions, still they have not even, they have just get the amendment only ready. So there is still scope over there. And blue states are where it has been passed, we're waiting for the cabinet approval. So, and these are the states where it has been implemented actually. Okay, when it comes to our subject, so as per the current code, like the maximum U value and the SSGC is 3 and 0.27 for majority of the climates. Cold we will not consider because cold requirement is something different. As we know, SSGC for cold we need in a higher value. So if you see the stringent of the current code, ECSPC, this 3 has become 2.2 and then 0.27 has become 0.25. And the one point thing you should notice, it is not just the value, related to glass. If you see the value, it is like vertical penetration assembly, which means that this U value is something related to an entire assembly. So imagine what would be the U value requirement for a glass. If the code says that you need to have a U value of say 2.2, what should be the U value of glass then? Should it be lesser or more? So this is the current code as per this. This code says that you should comply with the U value, assembly U value to be 2.2. What I'm asking is then what would be a glass U value? Should be lesser, same, or more? I mean, it can be right or wrong, as I say. Okay. So generally, if you take the frame material, its U value will be higher due to metal. So the glass U value, it has to be still lesser. Then only as an assembly, it can comply with this value, 2.2. When it comes to the horizontal skylight, they have given the what is the maximum U value and S. So this is what applies to the commercial building. So we'll now see about the ENS code, which is for the residential. So again, what they have done is, again, this for ENS also, the applicability remains to 100 kilowatt. The one thing is that if you take a commercial building and residential building, the connected load is going to vary. So here we will take a connected load terms of 15 watt per square meter. Because generally we know residential loads will be lesser compared to your commercial building. See, again, it's going to vary, but then we want to have a rough figure together. So in that wise, like if you are having a residential building which is having a built-up floor area more than 7,000 square meter, then the ENS code will be applicable. So approximately your glazing area would come around 2,100 square meter. Actually, you might have seen this code provision with respect to ENS. So the main thing is, so generally when we buy, we see three things only: whether the home is having good ventilation, is it getting a good daylight, and or also an reduced heat. So accordingly, this code is also devised. So in terms of heat gain, they refer to RETV. And then, as I've told yesterday, if you remember, RETV does not apply for the roof. So they are considering for the roof in terms of U value separately. And then when it comes to natural ventilation, it is up to openable area. Openable window to floor area ratio. I think ma'am showed it from lead consultancy. She was showing a table with respect to this table. And daylight is this VLT to window to wall ratio, which we saw. Like, what would be the minimum VLT? Yesterday we saw one table, no? Like as the window to wall ratio increases, then the VLT reduces. So what was the minimum value?
It's
27. Perfect. So 27% is the code or any rating system would recommend. Similar to ECSBC, this code has also got ENS, ENS plus, and super ENS. So in this, they have like a kind of green building rating system approach. So you have to fetch certain points. So if you want to achieve ENS plus, then you have to comply with the minimum plus 30% of the total points. So this is the formula actually. Yesterday I was not talking about the formula. So this very simple formula only seems to be like very complicated. So what RETV takes, okay, when it comes to RETV, I said like it is the heat transfer that is measured across your building envelope. So if you take any building envelope, there are only going to be two components. One is going to be opaque and another is going to be non-opaque, glazing. So for wall heat transfer through the wall, we measure in terms of U value. And then the heat transfer to glass, we measure using two components, U value as well as SSGC. That is why you have got three components. So this is what you are opaque. So this component will take off your wall, and these two will take care of your glass pattern. So what they are saying, what is their heat transfer divided by your area of envelope, that will represent watt per meter square. So any idea what is the cap they have fixed on RETV? Yesterday we saw, no? To fetch a 1 point in residential building, what is the minimum value that we should achieve? So it is actually 15 watt per meter square. So the maximum RETV for, as per the current code, it is 15 watt per meter square, and also it is not applicable for cold. Why? Because it is considered only heat gain, whereas in cold you have to consider heat loss. That is why it is not applicable for cold. Going forward, what BE has planned to make this cap as even stringent that it will become 12 watt per meter square. Maybe in a couple of years, they will make the minimum value to be 12 watt per meter square. So as I was saying, so for example, if you are achieving a value of RETV, say 11, we were seeing, no, when we are going with the high performance class, we were able to achieve a RETV value of good value. So you see that, for example, if you are having a RETV of 11 in your project, then you substitute in this category where the RETV falls between here. And then you will get like 5 into 11 will be 55. So 66 minus 55 would be 11. So you'll be able to get 11 points, which we saw no. If you want to target the ENS plus category, then you need to achieve 30% of the total points. So in this way, if you are achieving RET of 11, you will get 11 points. So similarly, I mean, there will be other categories as well where you have to accumulate points. So we all know that class has got a role to play in reduction of RETV, and I mean reduced value of U value and SSTC will make the RETV to come down. So this is the example which we saw yesterday as well. So you can see clearly from clear glass if it is having a RETV of 20. Going forward, as I was mentioned, residential projects go with a single glazing alone. So I have mentioned single glazing. So with a single glazing, higher performance, you will be able to meet that 14.2, which is your complaints level is less than 50. So we are able to meet with this 2 performance level. In case if you are going for a DG in residential project, you will be able to meet 12, RET of 12. So we saw no, when you are having RET of 12, accordingly the points would be given. And this is the VLT table with respect to window to water show. And here also they are evaluating the daylighting, which we saw, UDA, useful daylight illumination. So if your floor space is say achieving 50% of your floor area meeting the UDA criteria, then you will be able to fetch 3 points in it. So for any clarification on this? And this is, I just want to give you an overview of NBC. Probably our colleagues would have already taken it. So if you see in NBC, the major code is IS16231. So that is the applicability, mostly, area of application for glass. So they have got 4 parts, part 1, part 2, part 3, 4. So part 1 is to deal with general things. What are the different types of glass and everything? And then energy and light, what are the performance parameters which we have seen? And with respect to testing requirements, part 3, which my colleague just now explained. And of course, definitely there is like different section itself, but then this also will talk about touch upon. And part 4 is something related to safety. So when it comes to safety glasses, NBC talks about only 2 types. One is a tough one and is on the laminator. For both the safety glasses, the code is IS255. It will specify what are the requirements and test specification that these glasses should meet. And HS glass is not recommended by NBC, but still there are certain builders who prefer HS, but then you can always check for HS requirements also related to code IS1698. So these are the general criteria which will be seen from the NBC. So generally, if you see what will be the safe thickness and what would be a deflection, stress pattern, and then we'll take upon the other performance parameters, U value, SSTC related to acoustic, fire performance, or water penetration. So these are the general things which we consider. And for all this, you can refer to your NBC. So for my colleague Karnika would be touching upon the detailed procedure when it comes to how to, selection of glass with respect to thickness based on your wind load and also for wind load, the code is IS875 part 3. So that is where you get the convert the wind speed to wind load, how much is it. And then as I was mentioning on apart from the thickness, there is also provisions for aspect ratio and then the span. So these are the conditions that the NBC would specify. And then of course the deflection and stress percent. So when it comes to safety with respect to human impact, it is defined based on your location, critical location of your application and based on the safety glass which you are going to use. So you can see if it is going to be a glass door near to the low area, it is very high risk, and closer to the glass door, it is like medium risk. And if it is above, you can take it as a low risk. Next. Okay, I'll just take you through the various cases which this NBC specify. Right. So As I was saying, for with respect to safety, the glass selection is based on your level of floor, and then based on the window sill height, and then based on the angle of glazing, whether it's a sloped facade or horizontal fenestration. These are okay. When it comes to first case, like when the glass, I mean the window is on the ground floor level, and then the height of sill is like 0.75, less than 0.75. Then you can use any sort of glass. You need not to consider a safety glass. Next. So this case, in this case, if you see when the floor height is this photograph is one, one more. So you can see here this HF represents the fall of glass, height of the risk factor. This is like the fall of glass. I mean glass which falls from the height level, and then HS is your sill level. So you can see that if the glass falling height is less than or 1.5, then you can consider a safety glass. If it is more than 1.5, predominantly where all our building design would apply. So it is recommended that you consider safety glass in this. So when it comes to safety glass, we saw toughened and laminated. So when it comes to facade, toughened is mandatory, but laminated is option. But when you go for case 4 and case 5, that is your horizontal fenestration, laminated is must. And then even your balustrade or glass tiling, they are also laminated is mandatory. That's what we'll be seeing in the upcoming slides. Next. So this is what I am saying here, tempering safety glass is mandatory in this case. Next one. So when it comes to facade, tempering is mandatory, but laminated is optional. Next one. And here we saw laminated as mandatory when it comes to. So these are the test requirements for laminated and toughened safety, just to give you an overview. Yeah. Thank you.